Okay, today I'm just going to do a short little talk. This isn't like really adding on too much about what they're going to ask about today. The question's pretty simple today. It asks a little bit about the Big Bang Theory, about the Doppler effect. So remember, the Doppler effect is how it works for sound and light waves, but how waves get compressed. If something is heading towards you, the wavelength gets shorter. If something is heading away from you, the wavelength gets longer. And we use the Doppler effect to look out at the stars and see that the vast majority of galaxies in the universe are headed away from us. So everything is expanding. So when we see, I don't know how much of this I want to erase over here. Let me grab this. Yeah, no, I got to erase some of it. And I don't even have my marker. I was bringing a marker back over here. I already had to get them to buy that board for me. This, if y'all, I don't know if y'all remember, this was not here for quite a while. I used to have my periodic table here.
Yes.
Yeah.
I forgot about that. It was like halfway through sophomore year.
I just got to do what they tell me to do. So we all need this one. It fell down when the building starts to get cold. The walls sweat and things don't stay on the walls like they should. So, condensation.
You see one where you can like roll them over here.
Yeah, but that costs,
put it like at the back
costs money. Yeah, maybe I should get one of those. That's actually a good idea. So listen. So we see that all the galaxies are expanding away from us, from this central point in the galaxy, which is not where we are at. We are somewhere else. But even, did I show y'all the raisin bread thing?
No.
Let me pull this up real quick because it won't take too long. There's a good example of this. Quick access.
Raisin bread have raisins in it?
It's more like raisin bread dough, but yeah, it has raisins in it, which doesn't sound like a great bread, but
No, raisin bread's not.
I'm a fan of cookies and breads with like raisins in them.
Raisin bread slaps.
hold
I
on a
love raisin bread.
Number 16. Come on. Yeah. Here we go.
So sorry about that.
Oh.
Maybe this is why you're good. Why don't you have a new board? There's more like
Because this board just keeps on surviving every year. So this is the raisin bread example, or the raisin dough. I don't know what they call it. Raisin bread dough. Basically, here's the idea, and this is a like everyday example of the universe expanding, and why when we look out, everything else is moving away from us. And the further away it is, the faster it's moving away from us. The closer it is, it's still moving away, but it's moving away a little bit slower. So you take raisin bread dough, and just like any dough, it's close your Chromebook. Just like any dough, it's going to rise and expand, and it's gonna expand outward as the yeast creates air bubbles. If you have raisin bread dough, the raisins act as galaxies, right? So it doesn't matter which raisins you pick. You can pick any raisin in here and measure the distance to any other raisin. Let me bring this over here so the online people can see. You pick any raisin, measure the distance to any other raisin, and when it rises overnight, all of those distances are going to get bigger. It doesn't matter which one you pick, they're all going to get bigger. Now, the further away it was to begin with, like if you go from this raisin to this raisin, it's going to get bigger. That distance change is going to be larger than, let's say, from this one to this one. It will be a little bit smaller. So like here, it went 6 centimeters, where here it only went 2. They both doubled, but the distance that it changed was bigger. And so a speed, if you were assigning speeds to these over the same period of time, overnight, 12 hours, whatever it is, this would be actually going faster than that one if you're observing from the Earth here in this raisin. And so this is kind of the raisin bread thing. We can see everything moving away from us, which ideally, if the Big Bang Theory is correct, means that the entire universe is expanding. If you play this backwards, like you record the videotape of the raisin bread expanding and play it in reverse, it's going to all shrink down until the raisin bread is not going to shrink down to one point, but the universe would shrink down until everything is real close, tight together, in one single point. And at that point, that's where we start to theorize about the singularity and about the Big Bang Theory. What I want to talk to you about today, because we've kind of been over all the other stuff, is what are the two possibilities for the end of the universe? And actually, we'll just use these slides because they're already here. Basically, we haven't quite figured this out yet, but the fate of the universe in a very, very far future time, well after the sun is burnt out and the earth is destroyed, who knows if humanity will even be alive then. But
Yes.
that's bold, but I don't know. We'll see. The fate of the universe actually depends on how much dark matter there is. Because at this point, if you just calculate the matter that's left in the universe, and we try to do this, obviously our calculations could be a little bit wrong, but I don't think it's really close or anything. If you calculate all the matter that we know about in the universe, this gravity point that's in the center of the galaxy that everything is, or the center of the universe, not the galaxy, that everything is moving away from, there's too much gravity here at the center and basically everywhere in the universe for it to just keep expanding forever. What we expect it to do from the data that we have right now is eventually it will stop at some point. The expansion will stop, gravity will take over, and it will pull everything back down. In the same way, this is a little bit of an extreme example, but it doesn't matter how high you throw a football. Doesn't matter how fast you get it going. You can put it in a cannon and get all the pressure you want, or have a huge explosion behind it. It'll go up real far. You might even get it to go up super far, like a mile or two. At some point in time, it's going to stop going up. It's going to float there for like a millisecond, and then it's going to start to come back down because gravity is going to catch it and pull it back in. And so this idea that at some point in time, the galaxy will stop expanding and it will start to contract again because of the gravitational constant of all the matter here. Instead of the Big Bang, it's called the Big Crunch.
But if you do that in space, wouldn't it just keep going?
So with space, there's always another gravity well. So yeah, you could get it out of the gravity of the Earth, but it's not going to get out of the gravity of the sun.
So then how does that make it? It's all going to go back to that point.
Yes, and that's what they're talking about with the Big Crunch is, with the galaxy-wide gravity well, as far as we understand today from the speeds that these galaxies are going and the gravitational constant, we try to add up all the mass that we're aware of, there will be a big crunch. Everything will stop expanding and it will start to head back in, at which point likely it will all come back to that same singularity, whether it's a black hole or whatever you want to call it. We're all going to end up in there and literally everything will be destroyed. And like we kind of talked about yesterday, there's not even a way to escape it because that much gravity is going to bend space-time. Space and time aren't going to exist outside of that point. So it's not like we could build a big ship and just hang out on the outside while it redoes the Big Bang or something. We don't even know if that would happen. It's kind of going to pull everything in.
Will it grow as it pulls more in? Like, will there be more gravity as it pulls in?
So yes, black holes grow, but if you're talking about everything, the way they think about the singularity is there's too much gravity that pulls everything in. And so it will grow to a certain point, and then I guess it will start to shrink because of the gravity. In the same way that when a star burns out, it collapses down inward. And so I don't know that we have a lot of math on that. That's kind of like a lot of theoretical stuff. But that is one of the possibilities that we talk about for the ultimate end of the universe is the Big Crunch. And let's see if they go to the next slide here.
And do you think it'll do it like in an instant, like crunch in an instant, just like it was?
No, it'll take like billions and billions of years, and likely we might have another problem. We'll get to the other problem before we get to that. So basically, this all hangs on the undetected amount of dark matter. Even if we add in all the dark matter that we know about today, we still don't have enough or we still have too much gravity to kind of pull everything back in. So there might be an undetected amount of dark matter that could sway the density of the universe above the critical density and result in this big crunch. Depending on who you ask, they're either going to talk about forever expansion all the way out, or they're going to talk about the big crunch. What this slide does not talk about is if we're not going to do the big crunch, if everything just continues to expand forever and get further and further out, that's another problem. And what that is called is the heat death of the universe. And essentially, this is the idea. Like I make tea over there. How long does it take for my tea to get cold and get the same temperature as the room? You know, not very long, like an hour, maybe less, depending on how hot it is.
Depending on what it's
And
Exactly.
yeah, it depends on what cup you have, but the idea is you have all these stars, you have all these galaxies. We've seen that eventually stars burn out. They use up all their fuel, they explode, they burn out, they turn into big gas clouds of gas. If you play this forward forever, the stars and the galaxies will just get further and further and further apart. It will take hundreds of millions, hundreds of billions of years for that light to reach you. In the extremes of time, even if we're still here, we find another planet to live on, the Earth somehow survives, which it probably won't. The stars are so far away, you can't see any of them. The stars themselves start to burn out, and there's no more hydrogen and helium left to create new stars. And eventually, everything just spreads out like the heat in my coffee cup. All the heat spreads out. It gets spread out throughout the universe, and you don't have any like heat point to keep life like ours alive. There's not enough stars. There's not enough light. There's not enough energy. It all just kind of becomes room temperature, and room temperature in space is way too cold for anything to survive, at least as far as we know it. So even if you're talking about spaceships, our spaceships use fuel. That fuel has to be created in a process that involves heat and compaction and combining of elements. And so, you know, those are the two like really depressing options is everything gets crunched back together and we have another scenario like what we had before the Big Bang, just like a singularity black hole where everything gets destroyed, or everything just expands forever until everything is so cold and there's no stars and there's really nothing left and nothing to see. That's the heat death of the universe. So not trying to like depress anybody, but that's I know. But this isn't going to be any less depressing, but we'll be long dead way before then. You know, I don't know about humanity. Maybe humanity will survive and our descendants will still be around. But that is like when we talk about the Big Bang, that's the next logical question is if we're right about this and we have all this evidence for this, well, what comes next? Like, where are we going? What's going to happen here? And those are the two things, either the big crunch or the heat death. Or I guess technically there's another option, which they don't really talk about a lot. But if you get enough, just like a solar system or a universe, like is the Earth ever just going to fall into the sun because of the gravity?
Yes.
No. Well, at some point in time, the sun's going to expand and destroy us. But we're spinning. We're moving enough to kind of keep that gravity at bay and keep ourselves out. We see the same thing with the Milky Way. We're not going to be sucked into the black hole at the center of the Milky Way because the Milky Way is spinning like a spiral galaxy. I don't know that this happens. I don't think we have enough information to know anything about this yet. But I guess if the universe gets that centrifugal force and starts to spin, everything could kind of just stay out and avoid that big crunch. And we could, even if it's not like permanent, you could extend the life of the universe by hundreds of billions of years. Who knows? Yeah, and I don't even know like what time frame they're talking about with the big crunch. If anybody has any estimates or anything, but that's what we're talking about. So Yeah, we just move it around. We make the Earth a big spaceship. So your assignment today, you can go ahead and open up your Chromebooks and take a look at it. It's just one question. It asks about Doppler effect and the Big Bang and different stuff like that. So if you have any questions, people online, please send me an email. Today should be a lot easier than yesterday, but yeah. And if you want to work on the assignment from yesterday, it is still open. Just go and follow the instructions that are in Google Classroom, and you should be able to get to it and at least get a grade on it. So thanks for tuning in, and I will see y'all tomorrow.